Yeah, so I will be talking about cybersecurity and AI and kind of giving a brief overview around it and kind of look at these two different sets of technologies and how they are kind of intersecting with each other, and from the legal perspective as well as from a technical perspective. On the agenda, I'll give a very brief overview of what is artificial intelligence, the good use, the misuses of it. We go into a little bit into the cybersecurity from the eye of the law in terms of legality of AI, the crimes, then cybersecurity laws around it, attribution, all those areas. And then I will go next into technical aspect, a little bit looking into the different areas of cybersecurity from an AI context and how we can build good and robust defenses against AI attacks. So those are kind of the areas, and I kind of give a conclusion in the end. So that's my presentation. From the AI definition, these are some of the definitions that you can find around AI, what it means. And if you kind of look the first three, you can kind of understand that there is a common theme here where we're specifically talking about how AI is dealing with the human behavior and kind of looking into the intelligence aspects of it and mimicking those aspects. So these are definitions of it, and Russian President Vladimir Putin said that whoever kind of becomes a leader in this space of AI will end up ruling the world. So these are kind of big words from him, and this means that AI has a lot of importance in the future. Um, so from a cybersecurity perspective, some of the uses of AI would be to identify and find security vulnerabilities and configuration errors. These can happen in any cloud-based or SaaS application where the application is configured incorrectly and the hacker can exploit it. So AI can help in here because you can train a model through supervised or unsupervised learning and kind of build this model which can, based on existing configuration and vulnerabilities that it was trained against, it can actually identify new vulnerabilities and kind of configuration and find them effectively. Also, you can quickly accelerate incident response through alerting because you can same way if a model is trained based on previous incidents and there's sufficient data that it can actually predict or accurately say an incident has happened, it can actually alert even though that incident may not have been detected yet by a traditional system. That's where predictive analytics comes in. That's what predicting future attacks means and detecting anomalies. You can kind of look at the past trends and something is completely deviating from the normal. It can identify if a user is was a user suddenly started accessing millions of apps from his machine, thousands of apps from his machine. Then in theory you can say that there is some program running on his machine that's actually automatically causing these issues. So AI can help in there. It can, on the financial side, can detect frauds and can help out to based on certain models. It can detect like something for fraudulent activities happening, money is getting borrowed from a incorrect account, and we have seen that. And if you are going into bank, if you're doing a transaction on a different website, you may get an alert from your bank saying, "Hey, we haven't seen this website being used for a credit card activity. Are you the person doing it?" So it can detect fraud or something like that. There is a term called error-free cybersecurity that's being used, which is basically means that you're completely secure, which is kind of impossible because there is always something vulnerability out there, and that's where AI is kind of being looked at as the savior, where it can help and kind of create error-free cybersecurity because there's no human involvement. There's configuration, and artificial intelligence is taking care of configuration. So on the so a couple of examples here. Captcha is a really good way for web applications currently to identify if a person who's coming in is actually a human or a computer. based on some of the challenge that it gives to the user. And these are currently generated through AI as well. And AI is always trying to, on attacker side, they're always trying to break it through computers, but the defending AI is still very powerful enough to generate these new captchas, which are hard for a computer to figure out. IBM also built a AI2 artificial intelligence machine for predicting AI attacks, and it is very successful. Up to was able to predict up to 84% of the attacks. So it's been pretty successful. On the misuse side, they're pretty scary misuses. You think of it as like if you can use AI to hack into autonomous vehicles, you can basically make the vehicle do anything. Currently, a lot of vehicles are getting automated. There was a study conducted where one of the system was one of the student was able to trick AI model to not understand the sign, the road signs, and trick make it fool to think of it as something different. So that in that way you can kind of make the vehicle do something else. Similarly, for drones, there is a concept of slaughter bots where you kind of build this huge army of drones and kind of send them over for any malicious purposes, like for military purposes as well, bombing and all. So this could be kind of very hard. And it's now, before the attacker was just a single person, now he could program these many systems to attack through AI. So on the you can explore a victim network. You can kind of have AI identify if there is open ports, missing some misconfiguration, and kind of set the playground attack surface, set the attack surface for doing the attack. Also, AI can be used for malware creation. Currently, we are seeing that there is a team in Beijing who developed something called Malgan, which is a tool that detects possible malware intrusion points within a black box system defended by a malware program, and they built this based on AI technology, so it can be used for malware creation as well. AI is considered a dual-use technology because it could be used for civilian purposes, for good and bad purposes, as well as for bad military purposes as well. And so it is. This kind of can have various implications on both ends. So as based on this, Stephen Hawking said that this is something that could be the worst thing for humans, because I mean it could lead to catastrophe if AI bots are able to do all the wars and whatnot. Then basically you're looking at a very bleak future. So he wants us to prepare for it and avoid it. In terms of cybersecurity breaches, these are some of the breaches that I put in here. There was a study conducted by one of the agencies where they said that this is from 2017. They said that from 2017 the cybersecurity damage is at 3 trillion. By 2021 it will be close to 6 trillion. So in 3 to 4 years the damages are kind of doubling, and ransomware would be hitting almost $1 billion. Similarly, McAfee reported that for average records lost per day, it's close to 1 million. It's a pretty big number. And also, like the US residents, this is a staggering figure that almost close to half of the US citizens are a victim of cybercrime. So it's a big number. So that means a lot of these cyber activities are able to penetrate into systems, user systems. So yeah, these are, and there are a couple of other. For all of these, basically AI is now being actively used for some of these cyber attacks, so that because it's more. It's a more freely available technology that is happening through frameworks and tools and whatnot. Yeah, so from the legality perspective, this is where we look at the law, and we kind of look at when AI is being actively used to do all these attacks and perform some of these things. Like should, and also on the defensive side, should AI be given a kind of a legal recognition? Should AI be liable, be held liable to defense against some of these attacks? Should AI have rights against all of, should I have its own rights? And should it be considered an entity, a legal entity, which means that it is considered like as like another person. And then a lot of complex situations arise from it. For example, one would be that how do you even enforce something like that? How do you give those rights, enforce those rights, or take actions against some of those activities that AI performs? And then AI is basically behind the scenes. A programmer or developer is writing some of these programs, and he may have malicious or good purposes for it. So if you attribute AI for committing, let's say, a crime, or if you or doing something wrong, then how do you do the attribution back to the original developer who may have had this malicious intent? Um, because it's hard to pinpoint to the actual owner of the AI, because AI may have over time learned something new and did something that it wasn't supposed to do. And so and it becomes more complicated. Some examples is like in Saudi Arabia, there's a robot called Sophia, which was given this legal entity status as citizenship by Saudi Arabia, and Sophia is basically an AI robot. So how do you then put rules and laws against that? And once you sell an AI product to a customer or buyer, then there are many questions around how can you actually communicate to the buyer what is the intended purpose, because AI might actually move out of its bound and do something which is not there yet. Um, so these are some of the challenges, and subscribing liability is also a big one. For all of these questions, there is a need for actually laws to be modified to kind of look into how you can deal with some of these situations. Uh, on the attribution side, if an AI is involved in breach and it is able to penetrate into a network, then should this be considered hacking? If it is considered hacking, then I think there should be like really strong consequences for such attacks, because AI attacks are generally more dangerous, they are more costly, and they're hard to detect as well, because artificial intelligence might, through botnets, might be able to spread across a network and attack through different separate devices. So you cannot, tracing back to the actual person could be very hard. So if an AI attack is identified, then it has to be a very strong punishment under the law. Uh, so again, in the same concept here, that existing laws need improvement, where we can kind of think about how AI breaches need to be dealt with. In terms of the cybersecurity laws, I've listed 3 laws here, and they are basically talking about the first one is the Future of AI Act, and this was an act that was passed in 2017, and future here stands for fundamentally understanding the usability and the realistic evolution of AI. And what this law talks about is tries to generally define what an AI is, and kind of understand what an artificial intelligence system is, and kind of categorize it into 2 areas. One is the general AI, which generic artificial intelligence, which is more around how human behavior is. It's kind of something in the future that will be built. And there is a narrow artificial intelligence, which is more like AI in the context of a specific thing, like AI being able to play chess games and checkers or something like that. Um, So in 2018 there was an act passed called in US. It is called AI Act of 2018, and this act was also around. This act was also building on top of the first one, and kind of coming up with dealing with the 21st century workforce, building it so that the current the new US workforce is able to understand the implications of artificial intelligence, deal with it, put it into context, and come up with defenses against it. Those were the two acts that I identified. China has also a very comprehensive cybersecurity law, and they have actually lots of articles around what cybersecurity is, the dealing with the legalities and the attributions around breaches, and they have started to amend it to actually add AI components in there as well. So they're kind of working on that area quite a bit. Singapore also passed the Cybersecurity Act, where they looked at the same thing, looking at cybersecurity from an AI perspective. So that was done in 2018 as well. So moving towards on the technical side a little bit, I'm going to give a little high level overview of how we can build defenses using AI against different types of attacks. So classification is a very important concept in AI, which basically means that we are able to classify the data into different buckets based on training a model from known data set, and kind of writing algorithms that can look at the data, incoming data, and identify which class it belongs to. And this is used for malware classifications, because malware attacks are happening. If a new malware comes in, you can classify that this is based on the type of pattern. This looks like this malware belongs to this class, and treat it accordingly. Similarly, clustering is a little on top of it, where it looks into putting these classification into new categories which are not identified. Predictive analytics looks at forecasting the future using AI, forecasting new attacks that may be happening based on existing trained models on different things. Uh, the network protection and endpoint protection are also two areas. The network protection is looking at making sure that obviously the network on the network side, any attacks can be identified using network unusual network patterns. And on the endpoint protection, we are looking at the individual machines to see if there is any malware that's deployed, or any ransomware that's deployed on those machines, and kind of use AI to detect them. And then application security, we want to look at different types of application level attacks like CSRF, or a SQL injection, or SSRF, using AI to detect and mitigate them. Um, so one of the key area is spam. Spam. This is the first area where AI was able to help out. Is spam detection, and the way AI is able to do spam detection is using classification algorithms, using supervised or unsupervised learning, where you basically provide you look at different keywords within the email, and based on the count of certain keywords, determine if the overall score, like thread score of the email is spam score of an email is matching a certain category, certain number is going above it, and in doing so, it is considered an spam as opposed to an actual email. And spam filters built on top of it to classify them into different areas. Image spam detection is also an area where you can use OCR to look into the content of an image, and give it a score, give it a score, and then identify if it's a spam or not. Another technology used in AI is decision trees, where basically you feed the data into these tree-based models, and they are able to move the data from one, make the decision based on if the else conditions to and go down a binary structure to identify the classification of an email. So this is a more advanced concept of how AI can be used to classify a spam. In terms of threat detection, malware threat detection, this is a very important area, because malwares are exponentially growing. We have a lot of different kinds, and they come all the time, and they can be classified into trojans, botnets, rootkits, ransomwares, whatnot. There are various different types, and traditionally the approach has been either using static and dynamic malware. I know this is where, in the static analysis, you would do is you take a signature of existing malwares or create a hash of it, and when new malware comes in, it'll basically look at the file and see if it is matching that hash, and if it does match, you basically say that this is an existing malware, by looking at the execution of the file. Whereas the dynamic malware basically runs the actual file in an isolated context to see what kind of system API it's calling, what sort of behavior it's doing, and if it identifies a known behavior, it will detect it. However, these two have worked well in the past, but with the number of new malware coming out, it makes sense to have AI-based detection of malware, where you're basically looking at basically what you're doing is you're creating these models that are used to detect a malware on the fly, and one of few of these are basically decision trees. Again, you look at different code areas, classify them, and basically use those to make decisions. Also, KN model, KN model is also used to algorithm is used to detect some of these malwares faster. Phishing is also a very common area where you use emails to kind of trick people into doing something wrong, and AI has been useful here there as well, using some of these algorithms. Um, on the network anomaly detection side, we're looking at network traffic to classify and see if there is something that is an actual attack that's happening based on network latency or throughput. And intrusion detection systems traditionally have been built to detect them, and the traditional detection IDS would be host or network based, where they would look at a host system to see if there is if there is a known signature of attack that's happening within the host, or they look at the network traffic to see certain patterns. However, now there's a third class coming with AI, which is anomaly-based network detections, which start looking at different anomalies that are having within the network, based on predictive analytics and some AI-based algorithms, and kind of put them into detecting intrusion early. So it's used for classifying different types of network attacks as well. Botnets can be detected through it as well. Botnets, as everybody kind of understands, like you kind of have these various machines that are spun over and working towards doing different types of attacks. Like example would be a DDoS attack, or credit card. Detecting credit card information. So those can also be solved via machine learning algorithms more efficiently. On the secure user authentication, the authentication abuse prevention is a key area where now there are these fake logins that people kind of that are get created and used for different types of to do different types of activities, as opposed to actual human using those fake accounts. And in AI, what concept is called account reputation scoring, where you basically look into giving a score to an account based on the type of activity that's happening, how much login, how many times the account has logged in, or what kind of script are there scripts running only from the account, are there specific human like patterns in the account. So those are used based on different ML algorithms to identify kind of an anomaly account. Uh, is so a couple of other things that are interesting is you can actually also look at keystroke patterns of people typing in, and this was research conducted by Coursera and some of their students to identify just like how handwriting we can identify based on handwriting who the person is. We can identify based on keystroke patterns, like how quickly a person types, or what is the latency between typing of different keys to attribute to an actual person versus, like, let's say a bot or a program. And then biometric authentication, where you can look at use AI for facial recognition to understand what if it's an actual person, and facial classification to classify what kind of a person he is, to be able to recognize an actual person. Uh, so yeah, conclude this. I talked about from two perspectives. We looked at cyber, gave an introduction on AI. Looked at AI from the side of law, and from the technology perspective, like how cybersecurity and AI are getting used. And so if you can see from the gist of this presentation, cybersecurity coupled with AI is bringing a lot of complicated legal as well as technological challenges, and that need to be addressed. On the technology side, has been a lot of investment that has been done. There is still a need for more. However, there is a lack on the legal side to come up with a cyber framework to deal with AI related crimes, to deal with attribution, to deal with with making AI a legal entity. Dubai, an example is Dubai has come up with an AI strategy for 2030, where they're working towards making AI an actual law within the country, within the country. And yeah, so the conclusion is more holistic approach needed to adopt building these cyber security frameworks. There is a big need that the technology folks and policymakers and lawmakers are actually working together to come up with a comprehensive cybersecurity strategy in the context of AI. And also, there is a need for international cooperation between the different countries to come up with a global strategy for dealing with these issues. That's the entire presentation for me. Thank you.